Yeah, hello everyone. Yeah, welcome to my YouTube channel. Although when I'm still in basic mode. So what I was looking forward on doing today was to look at the concept of real analysis, and I'll be dealing with the neighborhoods. With neighborhoods, what are these things? Well, they say if we let epsilon to be greater than 0 and a belong to a real number, then uh, then epsilon neighborhood of a um, is given by the notation such that this is a set given by the elements of x belonging to real number in such a way that x minus a is less than epsilon. What does this mean? Well, for one to understand this thing fully, we need to try and visualize this as a set of numbers. This is a set of numbers. We can call this set maybe set M. Now inside this set M, there are some numbers here in such a way that A is the center number. Let's put our A there as the element A. And A is the center element. What does this mean? It means that the distance from A to the outer boundaries of this set is the same in all cases. So the distance from here to there, we can just call that distance, epsilon. So even the distance from A to the other left hand side is the same. It must be what? It must be epsilon. So a neighborhood of a number is just a set of numbers that are surrounding a particular number. So I hope this should make sense. Suppose we have a set of numbers, maybe 1, 2, 3, 4, 5, 6, and we are being required to find the center number A and the possible radius that we can get here. So for how do we do that? We first check the outer limits. Remember, this part here can be extended as a minus epsilon less x less than a plus epsilon. So you will notice that these are the outer limits or the outer numbers on the set, such that these numbers are excluded. So in our case, you will notice that we can say that this part here is presented by 1 and this part here is presented by 6. So x, these are just the elements which are surrounding some kind of particular number which is at the center of this set. So how do we do that? How do we find the center number? We'll just say a equals 2. Then we take 1 and we add to 6. We just say 1 plus 6. Then we divide by 2. Then we'll get 7 over 2. 7 over 2 will be our center element of this set. Remember, this set is just a set composed of real number. It belongs to real number, this set that we're talking about. It doesn't really necessarily mean that we're talking about integers. So now we've found A. How about the distance? And if we are to try and visualize what this 7 over 2 is equals to, it is equals to 3.5. So if we try to check carefully, we can see that maybe this kind of 3.5 is found in between 3 and 4. So maybe it's found somewhere there. Now the distance from this center number 3.5 to the outer limits is found easily by just saying the absolute value of 6 and we'll subtract 3.5 and we'll get 2.5 if I'm not making a mistake. And of course it appears like indeed you get 2.5. So it means that the neighborhood of E, our A is equals to 3.5 and our epsilon equals to 2.5, and this is nice. I hope this makes sense. So it will make sense if if I want to try and present this thing as the neighborhood of A. So for me to do that, I'll just say we have epsilon, or the neighborhood of A. Okay, This is how we present the neighborhood, such that we can present it in the form of, remember, we'll just consider those elements there as the elements of x belong to a real number, such a way that x will be less than a. I'll just try to recopy the general definition there, such that when we extend this, we can just simplify everything within that set, such that we'll just be having a minus epsilon less x less than a plus epsilon. And we can plug in the values that we know already. Our center number, we know already it's 3.5. So here there's no need for us to actually plug the values, because we already know that the outer limits of the set is just a 1, which is less x, which is less 6. So any number that is found within this range, then it is said to be belonging to the neighborhood of a. And that's a good place to stop.